All right, so first one, the position of a particle is given by this function, times are positive. For what values of time is the speed increasing? All right, when we look at speed, you have to look at both velocity and acceleration. You can't just look at one or the other, all right? So speed increasing, what does that mean about velocity and acceleration? Same sign. And they can both be positive, but they can actually both be negative as well, as long as they're the same sign. Remember my like jumping out of an airplane example? You would be going downwards and increasing your speed downwards. So as long as they're both, yeah, no, and that's a tricky thing. It's like, oh, they're negative. It doesn't seem like we'd be speeding up, but as long as they're the same sign. All right, so first let's find velocity. This derivative would be 6t squared minus 48t plus 90, and I'm gonna set that equal to 0. Now you're like, hey, Ms. Cole, why'd you set it equal to 0? Well, if I need to know where it's positive and negative, I need to know where those changes happen. So I'm gonna end up making a sign chart here. We did that last class too. We had a graph instead of an equation, but that's kind of where I'm headed. Right? I'm gonna divide through by 6. And then we're going to factor. So we're going to get t minus 5 and t minus 3. All right, so hold on to that for a second. I'm going to come back to this 5 and this 3. So just hold on to that. Because I also need acceleration. So go back to velocity. We're going to do the derivative of velocity. So that would be 12t minus 48. And again, if I want to know where acceleration is positive and negative, I need to know where it's 0. I need to know where the sign change happens. And so if I divide through by 12, that's going to give me t minus 4. And so that is going to give me time 4. So I like to make a sign chart. It keeps me organized. I think this was times are positive. So from 0 until, whenever. And I'm going to put velocity on the top and acceleration on the bottom. And the times that I'm going to need to put on my sign chart are 3 and 5 from the velocity, and then 4 from the acceleration. So 3, 4, and 5. And I'm just going to pick test numbers. Now, when you pick a test number and plug it in, you're not trying to figure out what the thing actually equals, just whether it's positive or negative. So don't, overthink this, right? So we're going to pick a number between 0 and 3 and plug it into velocity. I'm going to try 1. All right, 1 minus 5 would be negative. 1 minus 3 would be negative. A negative times a negative is positive. Notice I didn't waste brain power trying to figure out what the answer actually was. I just need to know the sign. All right, trying a number between 3 and 4, like 3.5. 3.5 minus 5 would be negative. 3.5 minus 3 would be positive. Negative times a positive is negative. To save time, the same exact thing is going to happen if you plug in 4.5. And then if you plug in something bigger than 5, like if we try 6. 6 minus 5 is positive. 6 minus 3 is positive. So that's going to be positive. And then for acceleration, we're going to pick test values and plug them into acceleration. If I pick a number in here like 1 minus 4 is negative. If I try 3.5, 3.5 minus 4 is negative. If I try something between 4 and 5, like 4.5 minus 4, that's going to be positive. And anything bigger than 5, that's also going to be positive. So I like making the sign chart. It helps keep me organized. We want where these are the same signs. So that's going to be 3 to 4, and then anything bigger than 5. And so that answer is E. All right, number 2. 2 particles start at the origin and move along the x-axis. This is our window times 0 to 10. Their respective position functions are given by, all right, so this is the first one, this is the second one. For how many values of time do they have the same velocity? All right, so we're going to get the velocity of the first one, we're going to get the velocity of the second one, and then we'll set those equal and see how many times they are equal to each other. So velocity for the first one, derivative of sine is cosine. And then for the second one, exponential is itself, so e to the negative 2t. And then I would have to chain on the derivative of negative 2t, which would be negative 2. I'm just going to write that out front. You can write times negative 2 at the end if you want. And then minus 1 is a constant, so that's gone. So these are the two velocities. I want to set those equal. So in my calculator, in y equals, I'm going to put cosine in y1, and then negative 2 e to the negative 2x into y2. And again, don't hit graph. Make sure you change the window to what was given. X is 0 to 10. And then we're going to hit graph. Now we just need to know how many times they are equal. So we don't have to calculate the intersections, just how many are there. And this is a little tricky because the exponential one, it's leveling off at the x-axis here, and it gets so teensy tiny, like so close to the x-axis that the calculator can't draw it in anymore. But you need to know that this graph does continue. So here, let me draw this. So something like that, and then the exponential one is doing this. So I know it didn't draw it in the whole way across, but we need to know it's there. So how many times are these velocities equal? How many intersections do we get? We don't have to find them, we just need to count them. And good, I was gonna wait and see if anyone else wanted to answer it, but good, there are 3. So that one is D. All right, number 10, number 3, ahead of myself. That window was 0 to 10, so that's where my brain is. The displacement in feet of a particle is given by S equals, I'm going to rewrite that as 1/6 t cubed. It means the exact same thing. I just like seeing that as a coefficient. That just, my brain works better with it that way. Time is measured in seconds. So this is position. This is the position function. I realize they called it displacement. It's just where the particle is. And the units are a big clue for you. If it's just feet, that's going to be position. So letter A, find the average velocity, average rate of change. This is average rate of change, and that just means slope. So we're going to find the slope from 0 to 1. So I need a point for 0 and a point for 1. So if we plug in 0 to this, we're just going to get 0. If we plug in 1, we're going to get 1/6, and then do the slope. So subtract the y values, subtract the x values. That would just actually equal 1/6, but you don't even have to reduce it. You can just literally leave it like that. But we do need units. So this was position in feet. We did a rate of change of that, so your units would be feet per second. So that was average rate of change. This is asking for the instantaneous velocity. So this is instantaneous rate of change. And so that means a derivative. We're going to actually find the velocity at time 1 second. So again, average is over an interval from 0 to 1. Instantaneous is at one particular time. So remember that Alice went for a walk thing that we did, and we like zoomed in on one point. It's just like that. So this velocity, you're going to bring the 3 down. You would have 3/6, which is 1/2, and then t squared. And they want us to plug in 1, so that is going to give us 1/2. And again, it's a rate of change, so the units will be feet per second. All right, so next one. This one has a lot of trig in it. So if you're like, hey, I want more practice with trig, here you go. Okay. 2 particles are moving. Here's our interval, 0 to 6. The position of particle P is given by this, so P of t, and position of particle R is given by R of t. And I don't see any units. There's not like any, miles per hour or anything like that. So we're not going to have any units in this problem. So letter A, for 0 to 6, find times when particle r is moving to the right. So what's going to be true about the velocity if the particle is moving to the right? That means the velocity is what, guys? And good, moving to the right would be velocity is positive. So I'm going to make another sign chart and just look at where the velocity is positive. So moving to the right in the positive direction, velocity is positive. Now wait, which particle was this? Because there are two. Particle r, so we're looking at this one. So let me get the velocity of this. That would be 3t squared minus 12t plus 9. I'm going to set that equal to 0. And again, you're like, Ms. Cole, but I want where it's positive. I understand, but if you want to know where it's positive and negative, you have to find where it changes first. So we're going to still have to set this equal to 0. I'm going to divide through by 3. And then that is going to factor into t minus 1 and t minus 3. So I'm going to make a sign chart for my velocity, and the interval they gave us was 0 to 6. So I'm going to start it at 0, end it at 6, and I need 1 and 3 to go on my number line. And so again, I'm just going to pick test numbers. I just need to figure out if it's positive or negative. I don't need to figure out what the actual answer is. So if I pick a number in here like a half minus 1 is negative, and a half minus 3 is negative. A negative times a negative is positive. And if I try 2 minus 1 is positive, 2 minus 3 is negative. So a positive times a negative is negative. And then if I try a number in here like 4 minus 1 is positive, 4 minus 3 is positive. So again, you're just checking real quick to see what the sign is. And so our answer is where the velocity is positive. So that's going to be from 0 to 1 and from 3 to 6. All right, letter B. Find all times when the two particles travel in opposite directions. So that means that their velocities, I don't know how to pluralize that, but their velocities are opposite signs. Opposite directions means the velocity of each of them is going to be an opposite sign. So we already found when particle r is moving right and left, it goes to the right and then to the left and then to the right again. We're just going to repeat exactly what we just did, this process for particle p, and then we're going to compare them and see where they are opposite signs. So what we did in A, we're going to just do that again. All right, so let's find the velocity for particle p. Derivative of cosine would be negative sine, so it's going to be negative 2 sine of pi over 4t. And then there's a chain rule there. I have to chain on the derivative of pi over 4t, which would be pi over 4. Now you can write times pi over 4 at the end. I'm going to just erase this coefficient and fix it. If I multiply by pi over 4, 2 times pi over 4 would reduce to pi over 2. It's 2/4 reduces to a half. So this is going to be pi over 2. I'm just writing it there instead of at the end to try to keep it less cluttered. But you can certainly write like times pi over 4 at the end. It means the exact same thing. All right, and so we are going to set this equal to 0. Again, if we want to know where it's positive and negative, we need to know where the zeros are. That tells us what to put on our sign chart. So I'm going to divide over this negative pi over 2. 0 divided by anything is just going to be 0. And so here we're running into the step where you guys did not get an adequate amount of practice with this last year. In fact, basically none with solving these equations. What we need to do is look at the unit circle and find places where sine is 0. Sine is the y value. So I need places where the y value of the point is 0. And that's going to happen right here and right here. So again, sine being 0, sine is the y value. Those are the two places that that's going to happen. So I'm going to get two answers. I'm going to get pi over 4 equals, this first one you haven't rotated anywhere, so that's just 0. Oh, whoops, I forgot the t. Please don't forget about the variable. I'm so sorry. And so that is just going to give you t is 0. And then what is this one over here, guys? How far did we rotate to get to this point? It is 180 degrees, but we don't do degrees in AP Calculus. Everything is radians. So you're not wrong, but they're not going to take that answer. It has to be radians. There we go, 1 pi. So we're going to get pi over 4t equals 1 pi. So the pi's are going to cancel. And so you'll have 1/4 t equals 1, and so t equals 4. So I'm going to make a number line, and then these are the two values that are going to go on my number line for my velocity. And again, our interval was 0 to 6. Oh, I guess 0 is already on there, so we just need 4. So we just need to pick numbers in here to test, plug them into the velocity, and see if they come out positive or negative. All right, so let's try 1. If I plug in 1 to this velocity, I'm going to get sine of pi over 4. Sine of pi over 4 is square root of 2 over 2, but I don't need to necessarily worry about that. I just know that it's positive. So sine of pi over 4, that's positive, but I'm going to times it by negative pi over 2 out here. So that is going to end up being negative. And then if I plug in a number that's bigger than 4, or actually in between 4 and 6, so if I try 5 pi over 4, sine of 5 pi over 4, that's in the third quadrant where everything is negative. So I know that's going to be negative, specifically negative square root of 2 over 2, but just it's negative. And then times a negative pi over 2, that is going to be positive. So this particle moves to the left, and then it moves to the right. And so the answer to this whole question, and you're like, we've been doing this problem forever. Trig is sometimes like that, and I'm trying to do it, like do this part a little bit more slowly because I know we did not get enough practice with it last year. We want to know where these two particles' velocities have opposite signs. So we have to compare these two sign charts. So from 0 to 1, this particle was moving to the right, and from 0 to 1, I know I don't have 1 on here. You could put 1 on your sign chart if you want. From 0 to 1, this one is moving to the left. So this one's positive, this one's negative. So from 0 to 1, they are opposite signs, but there might be another interval, so just hold on. From 1 to 3, this one is negative, and from 1 to 3, that would be in here. This one's also negative, so we don't want that. And then from 3 to 6, this one is positive. So from 4 to 6, this one's also positive, but for that section from 3 to 4, this one is negative, and from 3 to 4, this one is positive. So also from 3 to 4. And again, we were just comparing the sign charts and looking for where they were opposite signs. It is difficult to compare two sign charts that are separate like that, and that's why I'll oftentimes put them together. Like the other problems we did where I would put it all on the same line and like put this one on the top and this one on the bottom. You can do that if you want. Just put it all together and put your pluses and minuses in, and it makes it a whole lot easier to compare them. All right, and then C, find the acceleration of particle P at time 3. Is it speeding up or slowing down or neither? Explain your reasoning. So let's find the acceleration of particle P. So here's the velocity for particle P. To get acceleration, we're going to do the derivative of that. So derivative of sine is cosine. So we'll have negative pi over 2 cosine pi over 4t. And then again, there's a chain rule. You would have to multiply on a pi over 4. Again, instead of writing it that at the end, I'm just going to multiply another pi over 4 onto this coefficient. So if I multiply on a pi over 4, pi times pi would be pi squared, and 2 times 4 would be 8. And again, you can write it at the end instead. I'm just trying to make it be less cluttered here. All right, and they wanted us to find the acceleration at time 3. So if we plug in 3, here, I'll write this whole thing out here. It's going to be cosine of 3 pi over 4, if I put in 3 for time. And then we're going to have to evaluate 3 pi over 4. I want to ask you guys, because again, now we just ran into a step where you guys did not get enough practice with this last year. So I'm going to ask you, but no one knows. I'm obviously going to tell you. It's like my job. But which quadrant do you think is 3 pi over 4 in? Which quadrant is that rotation going to land us in? 1, 2, 3, or 4? Right, good. The second. And so your reference angle is pi over 4. And so what are the sides of the triangle going to be? Yeah, good. They're both root 2 over 2, except one of them's negative. Which one's going to get the negative, the x or the y? Yeah, good. It's going to be the x because we went to the left and then up. All right, cool. So which one of these is cosine? We're trying to do cosine. Is cosine the x or the y? Yeah, good. A lot of you already typed x. So cosine is going to be this one. So acceleration at 3, it's going to be negative pi squared over 8 times negative square root of 2 over 2. You do not need to simplify that down. The only thing I'm going to do is cancel out the negative signs. That's it. I'm not even going to rewrite it. It isn't worth it. It's just a jumbled mess. I think like every math symbol possible is in there. Right, so that's the acceleration at time 3. They asked, is the particle speeding up, slowing down, or neither at time 3? You have to look at velocity and acceleration, right? So v of 3 is positive or negative. Well, here's our sign chart for it. Here's 3. Velocity was negative at 3. So v of 3 is negative. And acceleration, our negatives canceled out. So whatever this mess of a decimal is, acceleration is positive. So what do we get to conclude? Are we speeding up, slowing down, or neither at time 3? Good. So we're going to say slowing down at time 3 because v of 3 and a of 3 are opposite signs. All right, and I'm only gonna have time for one more. But like I said, I think there were only a couple more questions that I had for practice. I'll still do a video of myself going over them and then I'll post that for you. All right, so number 5, the distance in feet that a ball has rolled is given by this. It's in feet. So I know they said distance, but that means position. It's just where the ball is. So find the velocity after 2 seconds. All right, so that means find velocity, plug in 2. So that's an easy one. We're just going to find the velocity. That would be 3t squared plus 4t. And then we're going to plug in 2. So 2 squared is 4 times 3 would be 12. Plus 4 times 2 is 8, so 20. And we do need units. This one is going to be feet per second. All right, and then it says, how long does it take, so that's going to be a time, for the velocity to reach 4 feet per second? All right, so we're going to set the velocity equal to 4 and then solve that. So here's our velocity, 3t squared plus 4t. We're going to set that equal to 4. And then, welcome back to Algebra 2. We're going to subtract over the 4, so it all equals 0. And then we will factor that. So 3t squared, that's going to split 3t and 1t. 4, I think, is going to be 2 and 2. Let's see if that works out. This would be 6t, I want that to be positive, and then minus 2t, 6 minus 2 will give me 4 for what's in the middle. So if you set this equal to 0, you're going to get 2/3 seconds. And then I'm not going to be able to use this one. I'm only going to get one answer. Why is that? Why do I have to dismiss this one? Yeah, you can't have negative time. That one's going to give you t is -2. Yeah, good. You can't have negative time, so we're going to dismiss that.